Hello everybody, welcome to my live presentation. This presentation is the final task of step 5 Machine Learning Pass CS Internship program. My name is Maliheh Mahdavi Sefat, and today I'm going to demonstrate some data cleaning and data visualization using the powerful libraries of Numpy, Pandas, Matplotlib and Seaborn. First thing we need to do, we need to import the necessary libraries, and we do it conventionally by the aliases. We import NumPy as MP, Pandas as PD, Matplotlib PyPlot as PLT, Seaborn as SNS, and datetime as DT. We also use the magic command matplotlib inline to show the plots in between the code in the same page here. First thing we need to do is to choose a database, and for this presentation I chose a little database of mine. This is this Excel sheet file. I created this file at the beginning of the internship program to keep track of the time and how much time I spent each week. I have a copy of this here and I'm going to work on it. So this Excel file is in the same file as my notebook, so I only need to have the relative path. The relative path would be the name of the file here, csexcel path, and I pass this path to the read Excel method of the Pandas library and create a data frame named CSDF. When I call the CSDF, you see that Jupyter Notebook by default shows the first rows here and the last rows, the head and the tail, and in the last part of the out cell you see that there are 1068 rows and 12 columns. We can also get this information with the shape attribute, and it would return the tuple of the number of rows and columns. Another good attribute is the D types, and it would return the data type of each column. You see that we have date time in date column, step and week are floats, and duration is time delta. The rest are objects. That is because you see here I indexed one element of the start time, and when I get the type it is date time, but time is not a native data type of Pandas, so it only shows object. So first thing we need to do on each data set that we have, we need to clean it. To do so, we need to know how many NaN values, you see there are many NaN values here, how many NaN values or empty cells we have. NaN is short for not a number, and NAT here in the date column is not a time. They are the empty cells in my data set. There's a good isNA method, and it shows which elements are empty or NaN and which are not. And when I do a little aggregation with the sum function here, you see that we have 143 empty cells in the dates column, and we have exactly 1068 empty cells in the column 11. So this column 11 is completely empty, and we can easily drop it with the drop NA. I tell it to drop the NaN values in the axis 1 view, which is the column view, and how to do it: if any column there is all empty, I want it dropped, and getting the shape shows that now we have 11 columns. I can call the head method to have the first rows and give it a number to determine how many rows I want to see. I want to see the first 3 rows. Here you see that now we don't have the column 11 anymore, and this column 10 is almost empty as well. You see that it has only 2 full cells and the rest are empty, so that must be a mistake. And but the full cells might be important. I want to know which indices have data in them. So I define a non-nan indices variable, and I index it. I index my data frame on the not na, not nan values of the column 10. I want the indices and I want it to be shown as a list, so I use the toList, and the list is this 374 375. So what is this 374 375? You see here 374, here it is. These are two links, and that is another mistake. In my convention I put the interesting links in the social media column, but these two are in the column 10. So what I do is to copy these two cells in the next cells in the cells beside them, and then delete the column altogether. So I write a for loop for each index in the non-nan indices. I want whatever is at that index in the column 10 to be put at the same index but in the column social media 2. And to show you that part of the data frame, not on the Excel sheet but here in the Jupyter notebook, we could use lock and iLock slicing methods. Lock would slice the data frame explicitly, meaning the end range would be included, and lock is for slicing with labels, label-based slicing. iLock is index-based slicing, and it is implicit, and lock is explicit and label-based. So I give it the index of rows 374 to 380 and the labels outcome to column 10, and this is the result outcome to column 10. You see that we successfully copied these two cells in the previous cells. Now we can drop the column 10 without any worry, and I don't want to drop nan values this time. I want the whole column with whatever is in it, so I drop it and pass the name of my column to the column's key argument. Getting the shape again shows that now we have 10 columns, and head 1 shows the first row. You see that we have labels from date, step, week to social media 2, and this too was another mistake on my part, because now we don't have a social media 1 column. So I need to change the name. For changing the name of any label, there's a good method, rename, and we can pass the old name and the new name that we want inside the dictionary to the columns the key argument, and this time I do it in place. Last time here I made a copy and dropped the column and just replaced my data frame with that copy of the data frame, but this time I do this in place. This in place true changes the data frame. And columns is another very useful attribute. It returns a list of the labels. You see that we have social media, not social media 2. So we successfully renamed it. And what about the empty rows? As you see, getting the is NA summation shows that in some rows we have 143 empty elements. Which rows they are? We can get the same is NA and some of them, but on the column axis 1 view, and it shows that at the end of our data frame we have 9 empty elements in each row. We had 10 columns, but 9 of them are empty, and this is the tail of our data frame, tail method. You see that at the end we have nat for date and nan for the rest except this duration, and this duration here you see comes from a formula deducing the start time from end time, so it's always full, never empty. But we want to know which rows are almost empty, so I create a almost empty rows variable and give it a condition. If each row has more than 8 empty cells, I want them to show here, and this condition returns true for those almost empty rows and false for the rest, and summing them shows that we have exactly 143 empty rows as we guessed. Deleting these empty rows is very easy. I want my data frame to be the same data frame except those empty rows. So this tilde character is means excluding or except. Getting the shape now after this shows that now we have 925 rows. So we deleted the almost empty rows. Let's take a look at the sum of our NaN values again. We successfully cleaned the numerical columns except this week, and I know what happened in the week. At the start of this file, at the start of this program, I didn't record the week of the step for the step 0. I started to record the week from the step 1. So there are two main strategies to deal with the NaN values or empty cells. One is to delete them if we can without losing important data, and another one is to fill the empty cells. If we know or we can guess what could have been or what should have been in those empty cells, we can fill them. And here we know that I wanted the first week to be named 1 and the second week to be named 2, and we have the exact date, so we can fill these empty cells here. To do so, here I show you the step 0. I show you the data frame on the step 0, and you see the weeks are NaN, and there are 70 rows of them. To fill the NaN values here, I again use the lock index slicing notation. I want the date on the step 0, and here I use the ISO calendar of datetime library to get the real week of the year and deduce 1, deduce 7. This minus 7 is because the last week of February is the 8th week of the year. So I minus 7 here and put that number in the week for the step 0. And you see it starts from week 1 to week 5 here. So now we have 0 empty cells in our numerical columns, and we are ready to do some statistics here. The easiest one is to describe, and this is the describe function and its results. You see that it returns a quick statistical view or quick information about the numerical columns. Count is the number of non-NaN values, and the mean is the average value. We have the minimum, maximum, standard deviation, and we have the quadriles here. This 50 percentile is the median value, and we can also group our data frame with the group by. I group it on the step and then get the describe. You see that, for example, you see here, for example, the count of each step, the count of entry in each step is 70 for step 0, as we've seen, and more than 200 for step 4 and 5. We can also do another aggregation here on the CS group and duration. I want to know how much time I spent in each step, and you see on the step 0 I spent about 44 hours, and for the step 5 so far I spent almost 150 hours. So it's time to plot. For plotting, There are many plots that you can use and show, and it depends on your data and your data type and the story behind your data. What story you want to tell about your data, what information you want to extract, and what insights you want to gain from the plot. For my little database, I could draw some plots. One of them is the histogram, and I want the SNS hist plot. Axis X would be the step, and I want the data to come from my DataFrame CSDF. I put the color to pink, and with this fixed size PLT figure fixed size, I set the figure to be shown in the screen, inside my screen. I give it a title, and you see here again that for the step 1 and 0 I had less than 100 entry, and for the step 4 and 5 I had more than 200 entry. Another good plot is the line plot. When I give it my data CSDF, SNS line plot data CSDF, I just stretch the width of my plot with the fixed size to be more beautiful. It automatically chooses the week and a step and draws a legend here. You see that the step started from 0, 1, 2, 3, 4, 5, and the week started from 1, 2, 3, etc. A good plot also could be the count plot. I can count each the number of entries on each unique date here, and with this GCA I just controlled the number of labels to show here. They were very crowded before, couldn't be seen, and I just want once in every 20 labels to be shown here, and with this X tick I rotated them 45 degrees. You see that for example in this date I did more than 12 things on that day, and at least I have one entry for each date in my Excel sheet. Another very beautiful plot would be the line plot. To draw a line plot, I had to transform my duration data with this apply method. This apply method applies a function to each entry of a column, to each cell of the column. So to each cell of the duration, I wanted it to be transformed to the number of minutes. So I use the lambda function and apply to create another column, duration minutes, and I used it on the y axis. The x axis is the date again, and just draw a legend here to show that this dark blue line is the mean value, and this light blue shadow is the other values on that date. So you can see that after a step 0 and 1 I had a little gap, and in between the step 4 I had a longer gap. Another interesting plot is the box plot, and I can show you the box plot of steps and the duration minutes we just calculated. This shows that statistical information that we just saw. The bottom horizontal line here is the minimum value. These three lines are the three quadriles: 25 percentile, 50 percentile, 70 percentile, and the upper horizontal line is the maximum value. These circles are the outlier values that are not included in the box. And another thing I can do, I can calculate the start time, the starting time of my tasks, and show which hour of the day they started. So I create another column, time hour. I again use the apply method to apply the lambda function of calculating the hour of day, and draw the scatter plot, PLT scatter plot on the date and the time hour, and this is the result. Each dot that you see is the hour of starting my task or study item. I can even make it more beautiful and more insightful by differentiating, by showing another information, an extra information, by differentiating on another column. This hue is for coloring each step in a different color. I gave it the palette rainbow, and for this plot I draw a grid here and gave the determined the vertex from 0 to 24 for the 24 hours of the day, and you see that each step here has a different color. So the syntax was the SNS scatter plot, and we set the X and Y and hue, and the palette is just optional, and this is the beautiful plot we get, and this is the gap between the step 4 that you may know of. This was my presentation for data cleaning and data visualization. Thank you very much for joining me on this presentation. I hope you have enjoyed it as much as I did.